And anybody that knows anything about spearfishing knows that what I'm saying is true. That if you want to spearfish this fish, you don't aim right at the fish, okay? You don't aim right to here. Instead, the image of the fish is going to appear out here. It's going to be out in front of where the actual straight line would have been. And the reason is that the universe knows that light can traverse faster by taking this pathway and then changing the angle through here, through the air, than it can going directly this way. It knows that because it has built this cue up, which has got all the relative speeds and distances, and that's how it knows how to figure the pathway that's fastest. This is something that nobody has ever been really able to figure out, you know. Feynman tried to do it with this path integral, but if you actually look at the mathematics of what he's actually proposing, he concluded this. He said, number one, the path selection occurs exactly where I'm doing it in the algorithm at the time of the absorption. Number two, Feynman said that the universe had somehow compiled a past history of all possible roads. Well, I'm doing that too, right? And number three, Feynman surmised that the universe was somehow assigning a weight to each pathway, like the way trip routes are determined by taking paths that accumulate the least travel time. However, Dr. Feynman never figured out exactly how it was processed by the universe, okay? Now, actually, if you look at the mathematics he's talking about somehow taking the fluctuations of time in the future and the back into consideration. I have no idea how the universe is actually going to do that. When you look at his calculations, he talks about that. In other words, I'm not sure how he actually proposed to actually get it accomplished. He's saying that the universe somehow fluctuates backward and forward through time. And that the only way you can figure out the optimal path that's going to happen in the future is to go ahead and make sampling or somehow predict what's going to happen in the future and also in the past and make that consideration. And I'm not sure how it even can work. And the other thing, obviously, he's talking about an infinite number of records in this past history queue, okay? But the way I'm actually doing it here, this algorithm I've got, it works in the forward-only arrow of time. In other words, it's doing this optimization that somehow nobody can actually figure out how it actually works. How the light somehow knows as it's approaching the surface of the water that your eyeball is going to be somewhere off beyond that, and the refractive index of the water compared to the air is going to be some ratio, and it somehow knows where to hit the surface of the water that you're looking at to figure out where to spear that fish. Light actually does this. Light actually takes a shorter pathway and then it changes because it knows somehow before it even hits the surface of the water that after it breaks the surface of the water, you're going to be standing there to get it. And somehow it knows that in order to do that, it's faster to go this way than to go the direct pathway. The only way it could do that is somehow, like I'm saying, build up a past history and do all these things that it actually does. But the way Feynman proposed it, he's saying the universe fluctuates back and forth through time somehow. And I'm saying no. I'm saying what happens is that the potential pathways are accumulated in these data structures that I've got clearly shown here. And that the queue keeps building up. And at the end of when an absorptive particle is eventually struck, it can take the contents of this queue and optimize the fastest pathway that to use. And that's how it can do this magic that you can never figure out how it's done. But not only can it do it, it can also do it in the forward-only arrow of time. And I don't think Feynman, I don't think he explained that. I don't think anybody explained that.